The wind is coming. I'm Mark Sponsler, and welcome to the Stormsurf Videos Surf Forecast for the week starting Sunday, January 30th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we see the last little bits of a gale generating 33-foot seas, pushing up towards the eastern Aleutians. That has produced a little bit of swell. Very tiny swell, radiating mainly towards the U.S. west coast. And then beginnings of a new gale starting to develop on the dateline with 24-foot seas, something like that. And this one will be aimed more at Hawaii. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, a dip in the jet, and we see it right there. We know from looking at the significant wave heights charts, there's two little gales, one there and one roughly there. What the jet stream does is when it falls south like this, that creates a counterclockwise flow aloft and down at the ocean surface. That is the hallmark of low pressure. And if low pressure is strong enough, it generates wind. If it's strong enough, it gets traction on the ocean's surface and generates seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. It all starts with the trough, and we have a reasonable one here. Winds look really good pushing off Japan to 210 knots, falling into this trough, but the trough won't last very long, and that limits its potential to generate storms and gales. So we get into Monday, you can see the trough pinches off instantly. Winds still, though, quite solid at 210 knots from Japan almost to the dateline. Dateline's right there. The split point in the jet, about 160 west, basically just north of Hawaii. And that's likely where it's been and where it's going to stay for the foreseeable future, which poses a series of problems. We'll talk about that in just a second. But as we get into Tuesday, more of the same. Notice the split jet stream here. That creates high pressure aloft between the two flows of the jet stream, whereas a singular consolidated jet stream, if it can form a decent trough, really supports low pressure. All right. Now, the issue here is the split point. Right here sets up high pressure pretty much locked over the U.S. west coast, especially California. But you can see the jet falling down through along the coast of British Columbia here. Good for producing snow into like Whistler and that area, maybe down into Washington, and then pushing into the interior U.S. But as far as California or even maybe southern Oregon is confirmed, pretty much high and dry. So we get into Wednesday. Same basic pattern, same thing on Thursday. The winds back off a little bit in the jet. You can see just barely 190 knots, which is still quite strong. In normal years, we'd get excited, but for whatever reason, there's just no major troughs are able to form or are forming. So that limits, again, the ability to produce gales. As we're into Saturday, well, nothing's changed. Split point is at 160 west, winds are 200 knots, and high pressure over the U.S. west coast. So we get into Sunday, almost a week out, really, no change. And then we're at 180 hours out, still no change. So a little bit of a early teaser here. We think a lot of this has to do with the MJO, the Madden Julian Oscillation, and the fact that it's been active, it's currently neutral or moving towards neutral, and then the forecast suggests maybe it will weaken and go inactive. And when that happens, that steals energy from the jet stream. Then we think the jet will unzip. The split point will move further west. And if that happens, see this ridge here? Well, if the ridge was up here and then falling down the U.S. west coast, then there would be potential for precipitation. But with the split point right there north of Hawaii and high pressure just locked over California, there's just no hope for precipitation. And though we've done pretty well, we need more. And so we're hoping this inactive phase of the MJO that's coming will give us a little bit of a break. But we'll see. Next up, surface level pressure, surface level winds. No big surprise here. Low pressure system near the dateline generating 35-knot winds aimed at Hawaii. Another system with 40-knot winds up over the north dateline region, roughly, almost the eastern Gulf, but not quite there, or the far northwestern Gulf. Most fetch aimed up at the north, not really generating a whole lot of anything. So we get into Monday, the gale. The second gale, or that first little gale, starts fading out. The other one's up in the Bering Sea, of no interest. That's all gone as we get into Monday night. Tuesday, another system develops, 45-knot winds. You see a lot of fetch here, but all this is aimed north. It's that little bit of the hook, the curl right here, with 35, 40, maybe 45-knot winds aimed at Hawaii again in the U.S. West Coast. A secondary fetch behind that with 30, 35-knot winds. So we get into Wednesday night, and then, Tuesday night and Wednesday, then that system starts pushing to the north, and yet here we go again. Another little system as we get into Wednesday night, developing 45, 50-knot winds on Thursday, pushing over the dateline, again lifting northeast. The jet stream's coming right like there, and then splitting, going up to the north. So standard thing, it's like a machine. The storms form near the dateline and then instantly get shunted to the northeast, and they get little traction on the ocean surface, and you don't get a whole lot of swell production from that. And then even as we get into Saturday, another little one lifting northeast, and then Sunday, another stronger one with 50-knot winds behind that. This one actually probably looks the most productive of any of them, but it's a week out, so the models always overhype things a week out, so we don't believe that either. So small gales is what it looks like for now. Limited traction on the ocean surface, small swell at best. All right, so a gale. This is significant wave heights to the North Pacific Ocean. We're going back in time to Tuesday. What was that, 4 or 5 days ago? A little gale formed over here in the far northern dateline region. It produced swell that hit Hawaii over the weekend, and that swell is radiating into California. The outer buoys are starting to show it. Nothing significant at all, 4 feet at 14 seconds or something like that, and some percentage of that energy will actually make it into the northern California coast later tomorrow. We have no high expectations whatsoever, and then there's another issue, wind, which we're going to get into in a minute. Anyway, we got into Friday, another little tiny gale over the northern dateline region, probably is going to do nothing. Then Saturday, here's the gale. This is the one we saw on the charts, and there's the current image right now. If we go back just a little bit on Saturday night, Sunday morning, seas were 38 feet for over a very tiny little area. So maybe some swell will radiate sideband swell towards California. But you see most of the energy. This storm was tracking to the north and northeast, and that's where most of the swell's going. So, all right, so let's go look forward. Here we are, 18Z Sunday. That system fades out or pushes into the Gulf of Alaska. Smallest system aimed at Hawaii will probably generate some swell. You can actually see the front right here moving into Hawaii roughly sometime on Tuesday. Small system behind that, again generating 37.1 foot seas, pretty far to the north and lifting north again. Sideband energy is probably it. Some other little spurious secondary energy generating 26, 27 foot seas in the Gulf. Another system as we get into Thursday, just one after another, but they're all just tiny systems. On the dateline, lifting northeast with 36.6 foot seas right there, building to 38 feet, 38.7 on Friday night. So maybe some hope from California, but certainly the Pacific Northwest from that one. And then as we get into Saturday, another tiny little system behind that, but this one is probably the more interesting of all of them on Sunday, just because it has more of an easterly track to it than a north track. The most energy tends to radiate away from a storm in the direction that the storm is traveling. So 40-foot seas at 06Z on Monday, so that's Sunday night, about 10 o'clock California time. And so maybe some hope, but again, the same caveat. It's a week out, don't believe it, but something to keep our eye on. All right, so not unexpectedly, high pressure, 1032 millibars locked. Remember, the jet stream is pushing right about 35 north, and it splits north of Hawaii with the northern branch up here, southern branch down here, and as expected, high pressure in control, generating some winds into the Pacific Northwest, but for the most part, a continuation of just pristine conditions along the California coast. But as we get into Monday, you see the high starting to ridge into the U.S. West Coast. So higher pressure, lower pressure inland. You get this wind production machine right on the edges of high pressure that's pretty typical. Get northwest winds, 25 knots on midday Monday, building to 30 knots over all of Northern California, and 15 to 20 knots down to Point Conception. Hawaii, not so bothered by this at all. And then as we get into Tuesday, 30 to 35 knot winds along the whole Northern California coast, 25 knots off the Central California coast. Does this smell like upwelling? Lots of north wind. Whatever warmth we had in the ocean, it will be gone after this if this all pulls out the way it's supposed to. And again, strong winds on Tuesday. We get into Wednesday morning, still 30 knot winds, 25 knots off the coast, a little bit lighter near shore. Hawaii doing okay, just light trades. Then we get into Thursday. The wind machine finally starts to back off. Cape Mendocino, that area, Point Arena, still 20-25 knot winds, but down from we'll say Point Arena southward, a light wind regime, if not likely light offshore. And then we get into Friday. Offshores are turned, the high kind of pulls away from the coast, probably because the jet stream, the northern branch, is pushing more north instead of northeast. I mean, just subtle variations in the pattern of the jet can make a big difference in local winds here. So Friday, okay, and then Saturday, you see, again, it looks like almost a summertime pressure gradient setting up here over Cape Mendocino. High pressure, 1038 millibar high right off Oregon, generating again 30 knot winds, but fortunately limited to just the Cape Mendocino area, most of Northern California under a lighter wind regime. Then we get into Sunday, same deal. Honestly, near shore winds will probably be northeast, light offshore. And there we are at the end of the model run, but more high pressure poised right off the coast. So who knows? It's too early to be spring. If it were late February, early March, we'd say, okay, it's pretty normal for California to get a significant wind event as high pressure starts building in earnest. This seems a little bit early to be a change into the springtime pattern, but we'll see. Precipitation potential for California. You all know what the drill here is. In fact, let's go back. Sunday, I mean, it was dumping pretty good up at Whistler. We checked out the cam there earlier today, and it was in the afternoon. Pretty good amount of snow. Wish we could see some of that in California. It makes it down to about the Oregon, North California border, and that's it. Brick wall. You can see the isobars from high pressure curving right in there, just locking California out like a brick wall. And we go into Tuesday, Wednesday, high pressure ridging inland, just nothing. It's all British Columbia and northward. Friday, nary a drop to be seen. The high pressure even pushing more into the coast as we get into Saturday. And then Sunday, nothing. Snow forecast dashboard for Olympic Valley, Squaw Valley. Nary a drop to be found. Same thing true for Sugar Bowl, Kirkwood, Mammoth. Literally nothing. Snow levels are the freezing level. Pretty high today, 10,000 feet. Supposedly falling down to about the 4,000 foot level on February 1st and 2nd. Would that be like Tuesday and Wednesday? But no precipitation, so just cold, dry air. And then slowly the level creeps back up to about the 10,000 foot range, and that's it. No cold fronts, no nothing. High pressure in control. Not so good. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation? We already talked about it a little bit. We're going to go way more into detail. And of course, what's going on with El Nino, La Nina? Well, we know it's La Nina, but let's see where we're going a month from now, maybe 6 months from now, maybe a year from now. All right, so the first part of the discussion is going to be about the Madden Julian Oscillation, that periodic weather oscillation. 2 phases, active and the inactive phase. The active phase is on one side of the planet, the inactive phase on the other. They rotate around the planet on the equator. Let's see, get in the frame there. from west to east. So the active phase, when it moves over the Pacific Ocean, then the inactive phase is over on the other side of the planet. The active phase is effectively a low pressure system. Low pressure, of course, creates clouds, and it can dampen winds, trade winds in the Pacific Ocean. The trades are driven by high pressure. When you get low pressure there, that reduces the intensity of the trade winds, and that can be good. It can also, it can actually reverse the trades, turn them westerly, in the far west Pacific, in what we call the Kelvin wave generation area. When that happens, it can take warm water that's normally pulled up there in the West Pacific, push it east under the equator, the whole way across the Pacific in what's known as a Kelvin wave, a ball of warm water pushing east. And then that eventually will erupt somewhere around the Galapagos or off of Ecuador and create a slick or a pool of warm water on the ocean surface. If you get successive active phases of the active phase of the MJO, they can create successive Kelvin waves, which can in turn result in the formation of El Nino. That is warm water building up in the East Pacific, creating precipitation. That changes the jet stream over the entire planet, and that is very productive for, or sets up a situation very productive for storms and swells in the Pacific Ocean in winter months. And it also is great for driving the jet stream into California, creating rain and precipitation and snow in winter months. Unfortunately, right now, we are in La Nina. The inactive, which is like a long-running inactive phase of the MJO, which basically supports high pressure over the Pacific. All right, so we're looking for signs of the MJO. Irrespective of what I just told you, we're just going to do a quick data analysis here of trying to ascertain what's going on in the Pacific right now. West Pacific here, East Pacific here. This is data from the TAO buoy arrays, series of buoys strung across the equator. There's the equator right there. So there's buoys all along the equator here, and they have not only temperature sensors that go down into the ocean, they also have wind sensors on them. We're looking at the arrows, not the colors. Those are water temperatures. But right now we're looking for wind, evidence of the active phase of the MJO, that is westerly winds in the West Pacific. So we see the arrows in the East Pacific out of the east. The longer the arrow, the stronger the winds. Pretty strong out of the east. Over the Central Pacific, oh, there's the date line right there, 180. In the Central Pacific, Hawaii's about 158, something like that. Pretty strong out of the east. In the Kelvin wave generation area, just 5 degrees north and south of the equator, from 170 west over to as far west as you can go in the far west Pacific. Winds pretty strong out of the east. But it's not the winds, absolute wind speeds. It's, are these winds stronger or weaker than normal for this time of the year? So you go to this bottom chart. They call it anomalies. Winds, you look here, the arrows, pretty much neutral. So this strength winds, that's pretty normal for this time of year. Central Pacific, maybe a little bit stronger out of the east than normal. Same thing over here in the Kelvin wave generation area. So that would suggest maybe, certainly not the active phase of the MJO, and it's really over here in the West Pacific that the real signal of the MJO shows up. So this looks more like the inactive phase of the MJO than the active. Trades, a little bit stronger than normal. Wind speeds, wind directions for the past 5 days. Right, this whole planet on one chart. 0, that's the equator. There's South America, Central America, Hawaii right about there. New Guinea right there. Kelvin wave generation area right in here. It's hard to see the arrows, but the colors tell you the picture too. Blues are easterly anomalies, yellows, reds, westerly anomalies. So this would be the active phase of the MJO, let's say, maybe over the Central Pacific. Sort of looks like the inactive phase over the West Pacific. If you just go down January 25th, 26th, 27th, 28th, it's only 5 degrees north and south of the equator. Maybe not a whole lot has changed. So maybe an ENSO neutral pattern or some sort of weak, gutless active phase of the MJO holding over the Pacific, but not a strong MJO signal one way or the other. All right, next chart, same deal. The yellows and oranges are westerly anomalies. The blues are easterly anomalies. Let's orient ourselves. The date line runs right up the middle. This is the whole planet on one chart. All we care about really is the West Pacific. So from 135 east to about 170 west, Kelvin wave generation area. And and this is past performance here, December 31st, the whole month of January. You sort of go down here. You can kind of see in the Kelvin wave generation here, well, we had, looks like the active phase of the MJO, westerly anomalies, and yellows. But then a little bit at a time as we got into mid-January, the pattern is changing, stronger easterly anomalies. And today, moderate easterly anomalies in the Kelvin wave generation area, building as we go. This is for the next 7 days, so just the next week. So it looks like a building inactive phase of the MJO, and we were in a active phase of the MJO, now moving inactive. So we said the active phase of the MJO is like a low pressure system. Low pressure systems generate clouds. So this is a model depicting cloud cover, outgoing long wave radiation. Fancy words, sunlight bouncing off the ocean surface. If sunlight is bouncing off the ocean surface and you get a lot of it, well, that probably means high pressure, because high pressure typically gives you clear blue skies. And if you have less sunlight reflectivity bouncing off the ocean surface, then it's cloudy. All right, so this is the statistic model. Oh, and let's get oriented. South America, Central America, Hawaii, equator right there. New Guinea, Kelvin wave generation area right in there. Literally no anomalies, no stronger than normal or weaker than normal anomalies, no MJO signals. Same thing 5 days from now. We go out 10 days from now, really no change. And this, per the statistic model, suggests more sunlight reflectivity, these positive anomalies here, building on the dateline. So the inactive phase of the MJO with the active phase of the MJO here over the maritime continent. The dynamic model, they'll put it right there, the GEFS ensemble model, starts out the same, but it shows the inactive phase of the MJO building 5 days from now, pretty strong 10 days from now, and holding, though a little bit weaker, 15 days from now, 2 weeks from now, with the active phase over the maritime continent. So far, everything we're seeing says we're neutral right now, but we're moving towards the inactive phase. Of course, the inactive phase of the MJO steals energy from the jet stream, and we talked about this earlier. If it does that, we're hoping that'll cause the split point in the jet, which is currently like north of Hawaii, to backtrack some, maybe to the dateline or even further. And if that happens, so if the split point of the jet stream was, let's say, right here at 180 west, then the jet could maybe push north up here and then down the U.S. West Coast, ushering in precipitation potential. That said, we're not seeing it on the models for the next 2 weeks. But beyond that, we're seeing some signs of that, perhaps, on some of the long-range models. Phase diagrams, just another way to look at the MJO, the active phase of the MJO, its exact position and its exact strength. All right, the MJO moves from west to east, from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot right here, right smack in the middle of the chart, is supposedly where the active phase is, and it's hard to say, but my guess would be it's somewhere in the western Indian Ocean. And the forecast track, this per the statistic model, says it's staying very weak, and if anything, maybe moving to the maritime continent. The GEFS model suggests the active phase building 4 days from now in the far eastern Indian Ocean, moving to the maritime continent. And the further the dots are away from the circle, the stronger the MJO is. So a weak to modest active phase of the MJO building over the maritime continent. The upper level model here showing you potential for rainfall. Oranges and reds are dry air, greens are wet air. It's pretty obvious what's happening, even if you don't know where you are. You go, well, there's the active phase of the MJO, dry air just working its way across the chart here. 40 days worth of data. So let's orient ourselves. South America, Central America, 0 is the equator, New Guinea there. The greens, wet air, active phase of the MJO, kind of a weak signal, and whatever there is, it's in the East Pacific as we get into February, moving into Central America by the end of February. And here comes the inactive phase of the MJO over the maritime continent, but finally pushing into the Pacific in earnest about Valentine's Day. Don't get those 2 days confused. Take care of your Valentine. Anyway, moving across the Pacific the whole month of February, and by the 11th of March, pretty much out of the picture, active phase developing, pushing into the West Pacific. And a little bit more MJO madness. Let's dive in deeper. The 1 month forecast. Again, blues are easterly anomalies, the inactive phase. The dotted contour is the absolute inactive phase. So the dotted contour here is the inactive phase. The blues are the easterly anomalies created by it. The reds are the westerly anomalies. The solid contour is the active phase of the MJO. So you can see back in December. Oh, and the dateline, runs right up the middle right there. Really the area we're interested in is between these two tick marks. Just go right up the chart. That's the far West Pacific, the Kelvin wave generation area. So in December into January 1st, you can see these solid contours. Though they're not connected, it's the same active phase of the MJO making its way across the Kelvin wave generation area, pretty much out of it today. And then here comes the inactive phase, the dotted contour, getting not here yet, but you can see the easterly anomalies associated with it over the Kelvin wave generation area today. Forecast building by February 12th, strong easterly anomalies filling the Kelvin wave generation area. That again will be stealing energy from the jet stream, and that likely, we're hoping, will cause the jet stream to unzip and then at least usher in precipitation to California. Worst case scenario, it doesn't unzip, and then we end up sort of in the pattern we're in right now with just these continuous small, pretty much ineffective gales in terms of surf production and high pressure and north winds along the California coast. But it looks like the inactive phase of the MJO is just trying to get set up. About 2 weeks from now, it'll be strong in earnest over the Kelvin wave generation area, and then holding for another 2 weeks beyond that. And then finally, the 3-month CFS model. Past performance on the bottom here, the forecast at the top. Kelvin wave generation area between these two tick marks here, 120 east. It's really about 135 east, but you get the general idea. To about 170 west, right about here. You can see a definite pattern here. You can see the yellows are westerly anomalies, the blues are easterly anomalies, the active phase of the MJO, strong westerly wind burst here in early January. That was a good thing. That was the first real active phase of the MJO we'd seen since July, and really prior to that, not much, if anything, for a year prior to that. Here we go, you see, just eyeballing this, blues over the Kelvin wave generation area, inactive phase of the MJO. But you can also see that once you get to about March 3rd, after that, it's nothing but yellows in the Pacific. Unfortunately, winter is pretty much fading by that point in time. We would have liked to have been able to start maybe October with this pattern and then have it build after that, but we're not, and that's just the way it is. All right, so let's overlay the MJO. Let's see if we know what I'm actually talking about. And of course, we are. So, solid red contours, active phase of the MJO. Here was the big active phase in December, early January. Westerly anomalies, sort of a mini westerly wind burst associated with that. The dotted contour, the inactive phase of the MJO. Pushing over, there's the Kelvin wave generation here right now, peaking about February 14th, and then sliding out of here as we get into early March. Active phase setting up after that with westerly anomalies. A weak inactive phase beyond that in late March, early April, but it's pretty much weak with an active phase behind that, more westerly anomalies. Sort of looks like La Nina is fading and a more normal MJO pattern is setting up for the Pacific. Let's overlay the low pass filter. This sort of tells the real story. Dotted contour here, like the dotted contour here for the inactive phase of the MJO, but this is we'll call it the La Nina indicator. It's a high pressure bias. Okay, today, well, let's go this past winter. High pressure pretty much locked over the dateline. That's not every day, but it says in general the tendency was for high pressure over the dateline. But you see as we get in time here, this high pressure bias slowly moving to the east, and the solid contour here, which looks much like the active phase of the MJO, is a low pressure bias, a tendency more favorable to storm production. Today, just barely sneaking into the Kelvin wave generation area at about 140 east. But you see over time, moving further and further into the Kelvin wave generation area, building a second contour in the April time frame. Now, is this a harbinger for El Nino? We think probably not, but we think it's just a more of an indicator of a return to normal pattern. As we get into, this is April, right? Once you get into October, we expect this low pressure bias to be filling a good portion of the Pacific, and that would set us up again for next fall, 9 months from now, to be in a normal position, not a high pressure dominated Pacific Ocean dry situation, but setting us up for normal precipitation next winter, a normal swell pattern, and the death of La Nina. Thank goodness. So with that in mind, what's going on in the Pacific temperature-wise, all right? West Pacific here, East Pacific here. These little X's here, those are the X's on the anchor lines of the TAO buoys. Those buoys used for monitoring El Nino. Okay, those sensors collect data. It all gets sent up to a central processing facility. Use a model to fill in the gaps in between the anchor lines, and you can get a profile of where the warm water is, where the cold water is. Warm water today, 29 degree isotherm, 29 degrees centigrade. That's pretty warm water. Pretty much stable where it was last week. I think the dividing line here about 172 or 3 east. The 28 degree isotherm at what was that, about 177 west. That's about where it was last week. Now the 24 degree isotherm, it was cutting off at about 130 or 132 last week, moving east, but also you see it now starting to show up at the surface. That suggests that warm water is building into the east. Cold water here in the East Pacific, cold water does not support evaporation. It does support high pressure, which is exactly where we are right now. What we need is warm water pushing into the East Pacific to try to dampen the high pressure, get some evaporation going, and then maybe get us into a more normal pattern. But it's not the absolute water temperatures, it's the anomalies, differences for normal for this time of year. And a clear sign of a Kelvin wave, warm water pushing from west to east. This all year, the dividing line between cold water here in the east and warm water in the west was back somewhere around here, but over the past month or two, slowly pushing off to, what is this? This is about, I think this is 130 west right now, so almost south of California. And there was much colder, 4 or 5 degree below normal temperatures over here in the East Pacific, of course driven by La Nina, down to today just 2 degrees and weakening. In fact, there's another version here. This one paints the picture even better. Kelvin wave right here. It almost looks like there's more warm water wanting to dribble into the Pacific, but we don't have west anomalies to push it. But a Kelvin wave making it to about 125 west, so that's definitely south of California. Cool water, which was much stronger, much deeper, down to just a little tiny pocket here at just below the surface, maybe down 20 meters, and warm water there. That is a very, very good sign. There's been a persistent large reservoir of cool water, but this Kelvin wave, it appears, is pushing to the east and squeezing it to the ocean surface, and once it's gone, there isn't anything to replace it, and that would surely be the death of La Nina. Sea level anomalies. This is from the Jason 3 satellite. Orbits around the planet, and what it's looking for is, we strip out the sea heights, the tides, the wind waves, and is the sphere of the ocean higher or lower than normal? Cold water at depth, where are we? Right there. Cold water at depth shrinks. That'll create a divot on the ocean surface. A warm water expands, and when it expands, it creates a bump on the ocean surface. So you can use this to get a sense, just sort of confirm what you think temperatures are doing down 100 meters or so, 300 feet down in the ocean, without actually having to have sensors there or some way to monitor it. And you can see, okay, so let's get oriented. Equator there, date line there. It's kind of a weird chart. It looks stretched, but Chile, Peru, Central America, Yucatan there, Baja there, Hawaii right in there, New Guinea right there, West Pacific here. Positive anomalies, 10, 15 centimeters above normal, warm water. That is our Kelvin wave, pushing to, according to this, leading edge, somewhere right about there, about 130 west. Now, we did have minus 20, minus 25 centimeter anomalies here back in October. We're down to minus 10 centimeters over just a little tiny area, suggesting it's only on the equator 5 degrees north and south, so there to there that really matters. But we see a war going on between warm water in the west and fading cooler water in the east, and we suspect the warm water is going to win that battle. This chart paints the situation even more clearly. All right, time, a year ago, late January 2021 to today. This is the West Pacific here. This is the East Pacific here. Blue, colder than normal water. Reds, warmer than normal water. Last March or so, 1 Kelvin wave. April, another Kelvin wave, both driven by the active phase of the MJO. Another Kelvin wave. And then we got in July. It all fell apart. Cold water. Massive pool of cold water redeveloped, year 2 of La Nina in the October time frame. Now you can see, what do we see? Here's our Kelvin wave working its way across the Pacific, making it to about 127 west, something like that. And you can see the magnitude of the cool water just fading out and dispersing as warm water tries to make a foray into the East Pacific. All right, sea surface temperatures. Sea surface temperature anomalies. Differences from normal for this time of year. Eyeballing this, let's get oriented. Chile, Peru, Central America, Baja, Hawaii, the equator, roughly right down the middle of the picture here. We see blues, colder than normal water. Well, filling the whole area off of Peru, Chile, on the equator. There's the Galapagos right there. Out to about the date line, somewhere out beyond this. But if you've got a sharp eye and you've been following these videos, there was much colder water upwelling to the surface in this area even last week, and it's been doing it for a month or two. All of a sudden, in the past 3 days, the magnitude of these coldest waters has significantly decreased to just being cool waters now rather than starkly cold waters. But you also get the sense there's warm water trying to build here up into Chile. There's warm water building off of Ecuador. There's pockets of warm water along the equator. And the magnitude of all this what was very cold water out here around the periphery of the core, that's getting slowly warmer, and the coverage of these cold waters is decreasing. That is a good sign. That means that this area of cold water, which doesn't support evaporation, is weakening and maybe collapsing completely, signaling the death of La Nina. Thank goodness it can't come soon enough. Sea surface temperature trend for the past 7 days. This paints it really well, too. The Ecuador there, Galapagos there. The reds are warming temperatures. You can see it the whole way across from the equator, almost out, not quite to the date line, but to a point south of Hawaii. We need to see this warming continue, and we have every reasonable expectation that it will, because the subsurface cool pool is all but gone. It's getting pushed to the surface by that Kelvin wave that is right about here. So you can't see it. This is surface, but under the surface, there's a wall of warm water that's pushing to here. It's been squeezing that cold water to the surface, and there isn't any cold water left. So all of a sudden, temperatures start rising. So this, you can see it here. And the backed off view, sea surface temperatures anomalies again. The markedly cool waters that were here are gone. In fact, let's go take a quick look back in time. All right, there is those colder waters in early January, and then as we move into late January, you see them just the past couple of frames, they start dissipating. Hopefully this will, there we go, do it again. Early January, cold water, slowly fading out. And you see it right down in here too, the extent of these cooler waters, see that right in there? they'll start fading the last frame or two of the image. There you go, right down in there. All right. So that suggests, again, that La Nina is fading. The magnitude of the cold waters is dissipating. There's literally no more cold water left to gurgle to the surface, and a Kelvin wave and warm water is pushing in from the west, suggesting that temperatures, hopefully, will return to normal, at least get closer to normal in the near future. Sea surface temperature trend in the immediate Nina 1.2 region, that's the area right off of Ecuador and the Galapagos. Temperature's down a little bit today, minus 1.393 degrees, but they are warmer than what they've been prior to that. I mean, all of November, December, till about January, pretty cold down to the nearly 2 degrees below normal. Then started warming, little fluctuations. This is a pretty noisy area. The picture that really tells the story is the Nino 3.4 region. This is the area on the equator from a point south of California out to about the date line. Temperatures today, 0.582 below normal. The threshold in this region for La Nina is a half a degree below normal. Clearly, we were in the roughly just eyeballing this 3/4 of a degree to almost 1 degree below normal. Now we're almost in the normal range. Now, I'm sure this is going to bobble around a little bit, but based on everything we're seeing, we should be getting to half a degree below normal or better here pretty soon. So what does the atmosphere sense, or does the atmosphere sense what's going on in the ocean? I mean, the ocean and the atmosphere can be what they call coupled, interconnected. When you have cold water in the ocean, especially at the surface, typically, and no evaporation, then you get high pressure building on top of that. Likewise, when you get warmer than normal ocean temperatures and enhanced evaporation, you end up with a lot of clouds and rain and precipitation, and that can spell El Nino. All right, so a way to measure the atmosphere's response is to look at the difference in pressure between Darwin, Australia, and Tahiti. They've got good, records going back 150 years, maybe even more than that. I don't recall off the top of my head. But anyway, when pressure is lower in Tahiti, that means, well, Tahiti's over the Pacific. That means you have lower than normal pressure in the Pacific, higher than normal pressure in the Indian Ocean, and vice versa. When the index is negative, that means lower than normal pressure over the Pacific. So today, daily contribution plus 24.03. That's not good. That smells of high pressure. And you look back here and you go, well, wait, it was down to minus 24 at several points. But remember, we were in the active phase of the MJO, which is like a low pressure system. And that was in the January time frame. And now we're moving to the inactive phase, so it would not be surprising to see these numbers starting to rise. You can take some of the noise out of this, and average it over 30 days. Today's value, 1.83. Where were we? Well, we were higher a month ago, so that was the inactive phase. And now we're registering right about here. Now it's delayed because it's a 30-day average, right? But this was the peak of the active phase that really was focused over the Pacific in early January, something like that. So we'll start to see this number going up. Last year at the peak of La Nina, this was up at plus 19, something like that. All right, and the 90-day average. Stretch it out even further. It's sort of a 90-day look back in time. The value, plus 9.01. Where were we? Well, we've been about the same place. But, last year this was at plus 15, right around this time frame. We never got anywhere close to that. So this year's La Nina, weaker than last year's, right? And probably won't get any stronger, or maybe only marginally stronger at best. In fact, let's graph this thing out. Let's take a look. All right, so here we go. 30-day moving SOI graphed out. Negatives are El Nino, positives La Nina, if they're high enough. All right, back in January 2020, we were kind of neutral. And then our La Nina started in July of 2020, build up to plus 21 here, January a year ago. This past summer, it kind of crashed. We go, hey, maybe we're over with La Nina. No, it came roaring back. This is the inactive phase of the MJO building. And you can see the steady upward march from July onward. We peaked out at 14 or something like that, according to this, and then falling off now. Last year in the late January time frame, we were, well, here's late January, we were way up at 21. This year, we're down almost neutral. This is going to come up with the next building inactive phase, the MJO, but probably not that high. I'd say we're not in a bad place. We're in recovery. We're starting to recover. We got a ways to go, though. Bunch of hard work. And then finally, the sea surface temperature forecast from the CFS version 2 model for the official El Nino monitoring region, the Nino 3.4 region, that area south of California out to the dateline on the equator. Now this chart, we think it's hokey. We're showing it. We don't believe it. We talked about this last week. Right now, it's showing temperatures at about 3/4 of a degree below normal. But for whatever reason, it senses the temperatures are going to crash again as we get into April and go down to the minus 1.1 degree range, something like that, and then recover in July, but only go to about 3/4 of a degree below normal and stay there. And this is temperatures on the equator, not off of California, on the equator. We see literally nothing that would support that argument, especially with the incoming Kelvin wave. And though we think it's probably pretty weak and that it's not going to like fully erupt to the surface and create some sort of a big warm slick, we don't see any source for cool water to evolve either. In last week's video, we talked about this, and we looked at the consensus model of like the other 25 models on the planet that are used for monitoring El Nino and La Nina, and all of those, the consensus was we'll be in a neutral, normal temperature regime as we get into June, July. So this model sometimes is pretty good at seeing things other models don't, and it's holding rock solid for now, but I don't believe it as of right yet. Maybe that's wishful thinking on my part, but I don't think this is the real outcome we're going to get. So for right now, small swell at best from a series of very small gales, pretty much on the dateline. The split jet stream pattern is dictated all high pressure in control and expected to probably be in control for the next 2 weeks. A bit of north winds for the bulk of this work week, but then hopefully by the weekend, next weekend, we'll be back to a northeast wind regime. As the inactive phase of the MJO builds, the expectation is it will steal energy from the jet stream. The jet stream will split. The high pressure blocking pattern over the Gulf of Alaska will drift west some, not so good for Hawaii, but for California, that could at least usher in the potential for the jet stream to start doing the backdoor trough thing. And this is as much of a wish and a hope as anything. We are at 75% of normal snowpack. We need at least that extra 25%, if not more, to eke out a normal year. And that'd be a great thing. I mean, if all we got is 75% of normal rainfall, well, given the strength and the magnitude of La Nina, that would be horrible. But we're shooting for 100%. I think that's the best we can hope for. But if it doesn't happen by first week in March, I'd say the odds of it happening are pretty slim. So we've got this little window here in the next 2 or 3 weeks for the jet stream to unzip and allow the backdoor front pattern to happen. I don't know whether it's going to happen. It's more wishful thinking than anything, but I'm hoping it'll happen. All right, so that's beyond that. Well, we're hopeful that we will return to ENSO neutral for next year. It'll take the atmosphere 5 months to probably recover from La Nina. So assuming La Nina dies in the April, May time frame, maybe even a little bit beyond that, June, as we get into next fall, theoretically the jet stream could recover and we could be back in a normal pattern and be not in an El Nino enhanced pattern, but just maybe eke out a normal rainfall, surf, and snow pattern for next winter. But for this winter, well, we're just going to have to suffer with what we got. All right, so if you enjoyed the video, there we go, give us a thumbs up. We appreciate it. If you haven't subscribed, please subscribe. If not, the links to the video are posted on the top page of every page of stormsurf.com. That's the website. Most of the data you saw tonight, you can see it there. and make your own forecasts, follow along during the week, or just use it to look at surf forecasts and wave models and all the other good stuff for precipitation models. We got piles of them for the whole planet there. Weed through it all. There's a lot of data, but a lot of it can be quite insightful. And if nothing else, we'll do this again next week, same time, same channel. Thanks for watching.